Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And today we are going into, after we've done 2 episodes on the McKinsey developer productivity articles. The first one was about their methodology. The second one was about the reactions. Today I thought I'd bring somebody who knows more about metrics than I do. And who has thought more about metrics than I've done. So welcome, SleepyFox.
Thank you. Very happy to be here, Alex. Yes, I guess I have spent a while thinking about metrics. There was a time back in the kind of, 2010, 2015 when I spent time on the conference circuit doing a presentation called The Dark Side of Software Metrics. I have a background in physics, studied astrophysics at the University of Leicester, and I've always applied a quantitative approach to software development, which has led me down some interesting paths over the years.
Yeah, so I'm interested in a few things, but let's start, with the beginning. First of all, let's assume that you could measure productivity, whatever that means. You could define developer productivity, you could measure it, and it had no impact. The metric had no impact on anything else. I think there's still an issue about the error in measurement, right? Which we are not addressing a lot.
Yes. I don't know about you, but when I first started doing project management training, which was Prince 2 back in the 1990s, I was confused when I saw my first Gantt chart because there were no error bars. So you have that, that waterfall of tasks as it goes across the chart. And like at the end, you have like a delivery date. But there are no error bars on any of the individual tasks, and there's no analysis of like the variance of what the end date would be. So it's very confusing.
Yeah.
It's like, how certain are you of this?
And here is where, I have a background. Let's say I did an engineering university, but it was more focused on hardware and software engineering at the end. So I'm not sure I could call myself an engineer, let's say. But one thing we were taught is that any metric needs to have an error associated with it. But I think you got even more of that in physics and in science, right? It wasn't...
So there's a whole chunk of what they call experimental design, where you attempt upfront to think hard about what is it that you're going to measure and why are you going to measure it, and what instruments are you going to use to measure. Kem Kainer, who's someone from the software quality field, actually talks quite a bit about this. And he identifies 10 measurement factors that he calls them. The purpose of the measure, the scope of the measure, the attribute to be measured, the appropriate scale for the attribute, the natural variability of the attribute, the instrument that measures the attribute, the scale of the instrument, the variation of measurements made with this instrument, the relationship between the attribute and the instrument, and the probable side effects of using this instrument to measure the attribute. And you're like, wow, that's a lot of things to think about. I probably didn't even think about 8 of those when I was thinking about what to measure. And we also talk about construct validity, right? In experimental design, it's we're measuring this thing, but with this instrument, and is this actually telling us what we think it's going to tell us? And often in our world of business rather than the world of physics, we end up choosing proxy measures for things. And I think developer productivity is kind of in danger of really being a proxy metric, because actually I don't think that most of the people who are reading the McKinsey article are actually interested in developer productivity. I think they're interested in something else, right? They've got a thing that they care about, and maybe they're asking questions about that thing, and that has some outcome on their life, their career, their job, the company. So some questions that you might actually be interested in as an executive are, how much will this project cost? Because you're looking at capital allocation for projects. You know, you've got a certain amount of money budgeted for your spend this year for your department. Where are you going to spend the money? Where is that going to give the most value? Maybe you're interested in looking good in a boardroom, right? You don't actually want to know about productivity. You just want your numbers to be higher than your competitors' numbers. Maybe you've been told, like a certain website that we shan't name recently, that you need to fire 50% of your staff. Which 50% do you fire? Maybe, you know, Microsoft with stack ranking, or GE with its differentiation program. Basically, you know, you have to rate the bottom 10% of your workforce. You have to choose, like, say you've got 30 people in your department. You need to choose 3 people to fit into that bottom category. And, you know, not good things will happen to those people. So you've got questions, and you want to find answers to them, and you might think that somehow managing to measure developer productivity would give you an answer that might help you. And I'm going to argue that, in actual fact, this is not the case.
All right, so let's go first through your argument, why you think this will not help, and then I will try to push back with a few things.
Okay, that sounds good. So I think that as a culture, we're obsessed with measurement. It's everywhere, right? It's embedded in our society. Measure twice, cut once. Numbers never lie. Right from the time that we're very young in school, we're taught that something that has a number is objective and valuable and reliable, and lots of other words ending in -able. And things that are qualitative in measure, things that we don't have a number for, are somehow subjective and unreliable and just basically of a lower level of quality than something that has a number attached to it. And this is quite pervasive. And it occurred to me a while back that we've arrived at this position through certain meanderings of the course of history. And I think the Industrial Revolution has a lot to do with it. There's a particularly lovely quote by Lord Kelvin, the first scientist ever to have been promoted to the House of Lords. In Victorian Britain in 1883, he said, "When you can measure what you are speaking about and express it in numbers, you know something about it. But when you cannot express it in numbers, your knowledge is of a meagre and unsatisfactory kind." And that really kind of sums up where we are. Numbers are good, and not numbers, you know, come back when you have numbers.
And I think one thing that I've learned I like to look at history, in particular at cultural history. And it seems to be that there are some cultural roots to that, in that Western societies believe that they can change nature, but in order to change nature, you need numbers and so on. And then there was also kind of idealism with science, right? That we could explain everything and anything, and
Yeah,
and in
it
order
was
to get there, we needed to measure things and have equations.
it was a very Victorian thing. This idea of kind of causal determinism and idealism, that if you could precisely determine the exact state of the system right now, and you knew the laws of the system, then you could predict for all future times what state the system would be in. And it was acknowledged at the time that, of course, you couldn't accurately measure that because science had not advanced far enough for you to be able to accurately measure the precise position and momentum of all of the atoms in the world. But, of course, at some point in the future, it was reasonable to assume that you would be able to. And then at that point, you could potentially, like God, know exactly what would come to pass at any future time. And this seemed a natural progression.
Yeah. As I know from the history of mathematics, at some point they were trying to, I think it was Hilbert, right? He was trying to make mathematics complete by removing all axioms. And instead they ended up with Gödel's theorem that shows that you cannot, any mathematics will be incomplete. So
that was, that I think was the turning point. Gödel's incompleteness theorem really was the first nail in the coffin of causal determinism. Because, well, his second nail in the coffin, maybe, because he's basically saying that for any system, and he's specifically talking about mathematics, but for any system that you can devise, there will be questions that you can ask in that system that are unanswerable, that cannot be proven. And that leaves a very uncomfortable feeling in the mind of any scientist. It's like, well, the whole point of science was to be able to answer the questions, but now you're telling me there's like a whole bunch of stuff that we can't even answer, ever? Heisenberg, with his uncertainty principle, threw the first spanner into the works of causal determinism, because he proved that there is a fundamental fuzziness about the universe that is irreducible. It's not a case of just more and more accurate measurement, because there's a limit beyond which you cannot measure, Planck's constant. So things are of necessity fuzzy, uncertain, random, and that was a major upset to the world of science. Einstein was very put out and declared God does not play dice with the universe, and then spent the rest of his career trying to disprove Heisenberg and failing.
And for people who are not that familiar or are not that interested in science, let's say that also we have the same things in computing.
Oh, we do. The Turing's halting problem is another example, where it is impossible to tell. It is impossible to write a program that will tell, given any other program as input, whether that program will halt or not. So there is no general solution to the halting problem, which again is a whole chunk of undecidability thrown in.
Yeah.
Which
and this expands. I mean, there are some problems that we know are undecidable. There are some problems that we don't yet know whether they are decidable or not, and so it's quite complicated.
The people always, and I think Richard Feynman is a good example of this. later on in his career, he said that early in his career, he was aware of the incompleteness theorem. And like almost all scientists of his day, he was like, oh, yes, of course there are some problems that are unprovable, but no problems that are actually interesting, right? Not the problems that I'm dealing with. And only later in his career did he come to realize that the tower of science, where people work on things and other people work on the things that the people have worked on and so on, and it builds up and up and up and up and up. We're always building on things that other people have done before. And they did them before because they could do them, because they succeeded, right? So the thing that they were working on was provable. And we know this because they proved it, right? And then we built on top of that, and on top of that, and on top of that, and on top of that. And so where we are at this point, at the top of this tower of science, is this narrow, like, vertical peak of the things that were provable. But what about all of the other things? And Feynman later came to believe that, in actual fact, the vast majority of science was unprovable. And it's just a selection bias that has led us to believe that, that in actual fact, no, it's only those small things over there. And we don't need to worry about those because we're not interested in them right now.
Yeah, now going back to managers, I think if this is a hard message to understand for scientists, I can imagine managers.
Yeah. Well, we've had 100 years, right? I mean, Incompleteness theorem was what, 1927, right? So we've had just under 100 years for business to kind of wrap its head around the fact that, okay, there's determinism isn't actually really on the table anymore, right? We've got to think about things in a different way. We've got to embrace uncertainty. So, I don't know, we would have thought that 100 years was enough, right?
Yeah, I mean, hard to say.
But, of course, managers are going to say, well, that's science. I'm not interested in science. I run a business. I make money.
And as a business, you have some hard things to rely on, like the money you spend, the money you get, the difference, the profit, and some clear computations, right?
There's a problem there. Let's say, for instance, you spend £1 million on a project which adds a new feature to your website. You can measure profit, you can measure revenue, you can measure costs. And accountants are well versed in this. They've been doing it for quite some time. But it turns out, if you actually talk to an accountant, that these things are not quite as easy or clear-cut as you might imagine. So, for instance, the money that you spent on this new feature, how do you know that the revenue that was generated post the introduction of this feature, the difference in revenue from, say, what revenue you got last year, is that all due to this new feature? Maybe, maybe not. Maybe other things have been going on in your business, one would hope so, which will affect revenue. Maybe there are factors in the global economy and your marketplace, the environment, which affect your revenue. These aren't all due to your feature. So, how do you determine? This is the problem of causality, right? And Gerald Weinberg's causality paradox, which is that everything has a cause and an effect, and that you can tell which is which. So, it's actually quite hard because you can't do a controlled experiment in business. Right? You can't say, oh, now I'm going to take my feature away and see if my revenue drops. I mean, firstly, no executive is ever going to do that, right? Secondly, right, there's no alternate universe in which you continue along that timeline without releasing the new feature and seeing what your revenue would otherwise have been. There's no way to do that kind of double-blind experiment. So understanding the causality there is quite hard. So let's say, anyway, you finger in the air and kind of decide, okay, this much of this increase in revenue is due to the delivery of project A. Well, which teams are responsible for that increase in revenue? Is it just the development team? What about the sales team? What about the marketing team? Do they have anything to do with it? What proportion is their contribution? What about on your development team? What proportion of that is due to each developer? What proportion is due to the graphic designer? What proportion is due to the project manager? How do you allocate what proportion of that increase in revenue is due to each of those individuals? And it's very much like saying, what proportion of a frog's productivity is their left hind leg responsible for? And it's like, well, we can try chopping it off and seeing, but it's likely that the frog won't do very well. And you can't, and on its own, right, the left leg is no use whatsoever. Mm. So,
let me tell you a story because this was funny. I went on Saturday at a symphonic orchestra concert. There's a big festival in Bucharest that was closing now, and it was a big orchestra. And after spending some time with the McKinsey articles, I was looking at the orchestra, and I noticed there was one guy standing next to a big drum.
I can see where this is going.
All during the 2-hour concert, it was almost 2 hours, he only hit the drum like 3-4 times maybe. So that would amount for a productivity of, I don't know, 1%, let's say, 3%, right?
Oh dear. He's going to end up in the bottom 10% for sure.
Yeah, so...
Should be worried about his job.
Right. So what do you do about that? It was quite an interesting thing because on the other hand, I'm not very keen with using metaphors for software development because I believe most of the metaphors are kind of missing the point.
Every metaphor is a double-edged sword.
Yeah, but what you see in an orchestra, what I was thinking is you have a bunch of people who are working in unison. They have trained for that. They kind of accustomed to each other and so on. And it's probably the same with a team that's working not correctly, effectively, let's say. They have worked together, kind of learned how to deal with their weaknesses and their strengths and combine them and learn from each other and have all kinds of social dynamics in there that are working. And when you are coming and say, okay, let's take this guy out because he's in the bottom 10%, it's not only about that productivity that you are taking out, but it's about all the other connections and social dynamics and everything else.
The whole is more than the sum of its parts. Yeah. So apart from the, you fire that person, and then, what happens to the morale of the rest of the team as they all start looking around and wondering whether they're going to be next. But even if they were objectively the lowest performing member of the team, that doesn't mean that they aren't doing essential work. There was a really good blog post published about this a while back, talking about what they called glue work. And they were using the glue metaphor in two different ways. One to mean that it holds the team together. So they're doing a lot of emotional work and coordination work and communication work in both internal within the team and also like external with other teams. And they were also saying it was glue because if you do a lot of this, then you will end up stuck in your career, because the things that companies do to measure performance usually take absolutely no measure of any of the glue work. So it will look like you are unproductive, despite the fact that you're doing essential work that no one else wants to do. And no one else wants to do it because it's hard.
Yes, and I think this is a challenge. To me, all of this is a challenge with complex adaptive systems or something around this, because I think the intuition of managers is not up to... I mean, everybody's intuition is kind of blown out by complex adaptive systems, I think. And one of them is, teams that are working together and so on. Another one is the previous example that you gave with, if I add a feature to a web app, did that feature bring 200 more users, or is it because something else happened?
Google changed their SEO algorithm.
Yeah, because you live in an ecosystem and it's very hard to separate variables as you would do in a scientific experiment, like you say.
And even the scientists get it wrong, right? Stats is hard, really hard, even for the experts. And yet, we seem to think that business people, often with no training in advanced mathematics and statistics, can somehow manage to do this right first time without help. It seems unlikely.
Yeah. But now let's go a little back to maybe focus on the small scale. Like, I'm a developer. If I wanted to get better, is there anything that I could measure that could help me improve myself? That is an interesting question, I think.
It is an interesting question. So, and I'm not sure I have a good answer for it. I think one measurement that might be helpful is the amount of time that you spend stuck. If you can find a way of measuring that, then you can find a way of understanding what proportion of your work is unproductive, and then maybe think about why, and then maybe be able to address that. That is a measure that may be helpful. Time to complete a task. Perhaps it's worth understanding that. Not necessarily how long it is, but what the variability is. If you're doing roughly the same kind of thing, but the variability on that task is quite high, then that would seem to indicate that the skill level that you have in that thing is not very high. One of the first things I learned about driving on track from professional racing drivers was the very first thing you need to be is consistent. If you drive one great lap, one mediocre lap, and one terrible lap, it's like, well, what can you improve? And it's like, well, yeah, it's difficult to tell, really, because there's no consistency. When you can drive a lap consistently, even if it's consistently badly, then you can analyze your performance, and you can say, okay, I'm on this particular corner, I'm clipping the apex too early, so I'm losing exit speed. So let's just focus on that one thing to improve. And when I go out again in the next few laps, I'm going to focus on improving my performance on that corner and measure it. And then when I come back in, I'll look at my times and I'll see, okay, did that make a difference? Yes or no? Being consistent and achieving consistency, I think, is something that's worth measuring, because when you understand that you have reached a level of consistency, that enables a particular kind of learning.
Yeah, and I think one thing that might be interesting here, do you feel that it's the work in software development is very different from, let's say, from one task to another?
That depends.
It's a common argument that, software development is more creative and we cannot apply these things. And I think that part of our pushback to metrics is that we don't want to be held too much accountable for what we are saying. No.
Okay. So there's a couple of different points there. One is are we doing the same kinds of things? And it's undoubtedly the fact that for certain jobs, you are doing the same kinds of things. The boilerplate in producing a Spring Boot endpoint for a microservice is absolutely the same kind of thing. You talk to anyone who's done agency work in front-end JavaScript, there's a lot of same kinds of things that go on. So I think there are pockets where we are doing the same kind of thing, and that's the reason that stuff like Create React App exists, right? Is to help cut down that kind of, turn the handle, out comes the sausage kind of work. I do think that the majority of software work is, as someone once said, more like designing a factory than producing a car out of a factory or any other mass-produced item. There's a famous paper which talks about programming as theory proving or as theory building. And saying basically that producing a computer program is more like proving a physics theorem or a mathematics theorem than it is making a chair. It's intellectual work, and it's unpredictable. You don't know how long it's going to take you to prove a theorem. You might be able to do it today. It might take months. Similarly, writing a book. How many words can you write per minute? Right? Does that have any bearing on how long it's going to take you to write a book? Well, kind of. It has some bearing, right? Because, if a book has, 100,000 words in it, then there's a minimum amount of time in which it is physically possible to actually type that amount of words. But in reality, writing a book is going to take a lot more time than just typing the words, right? That's typing is not the bottleneck.
So interestingly enough, with writing a book, there's a subsection of book writing, which is taking a movie and writing a book from that movie, which is novelization, I think it's called, which apparently it's a very predictable process. So it's a lot like the boilerplate work that you are talking about.
A very predictable process for a very low bar of quality, I would imagine.
Yeah, I mean, of course, some novelizations are better than other, but I found interesting that there are some pockets that are predictable, like in software development.
Arguably, the person or people who wrote the script for the movie did most of the hard work.
Yeah.
And most of the unpredictable things were probably in there rather than in the transcription into novel format.
Exactly, yes.
I mean, obviously, there's quite a lot of kind of, how would you put it? Things that happen in the scene that are of a visual nature rather than the script that need to be transcribed in such a way that the person who's reading the book can visualize them.
Yeah.
So those things, there's an artistically creative element in being able to produce those in a way that the reader enjoys. But yes, I'm guessing that most of the uncertainty is in the actual production of the initial film script and the revisions that process goes through. Writing a book is quite iterative, after all.
All right. So writing code is more like proving a theorem. So it's fundamentally unpredictable, except maybe for some things that you do repeatedly. What about the second part? Do you think that some of the pushback is because we are running from responsibility, or?
I do think that, but I think this is a conditioned response. So we have been told since, I guess, we were small, that if we were told to do a thing, we were responsible for doing that thing. And if we were told that it should be done in an hour or 2 hours or by the end of the day or whatever, then we're responsible for doing that thing in that time, even if really maybe we didn't ever actually think or agree that it would take that amount of time. So I think we take on board a responsibility because at the back of our minds, we believe that if someone's told us, you know, we should be able to finish this in a day, then we should be able to finish this in a day, right? Because they're our boss or our senior. So of course we should be able to finish it in a day. And if we don't finish it in a day, it must be our fault. And needless to say, you know, you don't go very far in your career before it happens that someone gives you something that with the explicit or implicit, you know, condition that it should be done in a day. And at the end of a day, it's not done. And not only is it not done, but it doesn't look like it'll be done at the end of the next day either. And it's very difficult as an individual software developer not to take that as a personal failing, especially if someone asked you, how long is this going to take? And you said, I can have it done by the end of the day. And they go, good. And then they wander off and you go, can I do it by the end of the day? I don't know. I hope so. Yeah, and it doesn't take very long in your career before, you know, several of these events mount up and you end up with this feeling that, like, you're not actually very good at task estimation, or necessarily very good at actually doing the task itself. And this is where kind of imposter syndrome comes from, in part.
On the other hand, I feel that, so one thing that I've experimented with in the past years has been to take on a responsibility, even if I wasn't certain that I would be able to do it, and then learn from it. So if I manage to do it, then I've learned that I can, which is good. If I didn't manage to do it, then at least to look back and say, okay, so what would I do differently? And it's rarely the fact that I needed more time or estimate longer or something like. Sometimes it is, but often it is a different approach or a different way of going into it. So I think there are some benefits, at least at the individual level, because it gets really muddy when you mix it with corporate structures and management and so on.
Yeah, it has to be safe to fail, right? And absolutely, of course we can learn from the work that we've done. That is a central part of being a software developer, is learning. But there's something else going on. And that thing is at a fundamental level. So back in 2001, J.P. Lewis published a paper in the ACM called Large Limits to Software Estimation. And in this paper, he uses KCS complexity theory, which is a branch of algorithmic complexity, to prove 4 claims. Program size and complexity cannot feasibly be estimated a priori. Development time cannot be objectively predicted. Absolute productivity cannot be objectively predicted. And what's more, there is no estimator which produces a correct fixed bound on the complexity of all inputs. So what he's done here is not just assert, he has proven that you cannot estimate software development.
Wow.
It just is unestimable, right? It's like Planck's constant and the uncertainty principle. It's just software is not hard to estimate. It's actually impossible to estimate. Impossible in the same way that, like, you can't get information back from a black hole. Impossible. It's like a fundamental limitation in the mathematics of our universe. And thus, we should stop beating ourselves up about being bad at estimating how long, like, writing software will take.
Yeah, I mean, that was clear to me empirically for a very long time.
It is, but people keep telling you, oh, you just need to get better at estimating. You just need more experience.
Yeah.
But in actual fact, no, it's not true. And if you work in software long enough, right, you experience the long fat tail of software development, and something way out of left field comes and hits you. Back when the iPhone was first released, there was no software development kit for the iPhone, and I was working for a telecoms company that did voice over IP applications for lots of different phones, mostly Nokia Symbian Series 60 phones. And what we wanted to do is we wanted to produce a VoIP application, so a bit like Skype, for the iPhone. And so we got a couple of the first iPhones, and we hacked them using a really interesting little hack that had been developed by some hacker somewhere in the hackersphere, which relied on you telnetting into the baseband chip and issuing Hayes modem commands to unlock, like, secret God mode in the iPhone.
Oh boy.
It was some wacky stuff. Anyway, so we got to the point where we could actually we could cross-compile our own ARM code, and we could, like, upload it into the iPhone, and we could actually run iPhone applications before there was a software development kit, or even like an Apple store. With the sole intention of being able to demonstrate a voice over IP application on the iPhone at VON, which is the Consumer Telephony Conference in Boston. And the purpose of doing this was not really to like sell this application to consumers, because there was no app store, right? They couldn't buy it. The purpose was to impress investors in the company and get venture capital. I say, look how clever we are. We managed to produce a voice over IP application for the iPhone before there was even a software development kit. And we'd been going at this for about 2 months and making great progress. And we had about 4 weeks to go before the conference, and we hit a problem. And the problem was there was no duplex connection between the DSP chip and the baseband chip. So it was impossible for us to do normal two-way speech from user space on the iPhone. The iPhone's phone application resided in ROM, and the ROM did have two-way connections, duplex connections to the baseband chip. But the DSP that was used by user space applications, there was no connection, so we simply couldn't do it. Right? There were no wires on the motherboard to do it, and everyone was like, "How? What were the designers of the iPhone even thinking? How could they make this mistake?" And the answer was, well, they'd never made a phone before. They had no experience in mobile telephony. They were doing this for the first time. Of course there weren't connections. They didn't think they'd need them. And that just basically killed the project stone dead. No one could have predicted that.
Yeah, that is something that you find out by doing, which I guess I guess that's the way we do software, or the only way in which we can do software, like do stuff and figure out how far you're going or not.
But this is the essential nature of software, right? We're always doing something new, because if somebody else had done it, then, we'd just like Control-C, Control-V. Right? We'd just copy and paste from Stack Overflow, or we'd use a library, an open source library, or maybe even a closed source library that we'd buy. We'd if we don't just use an existing thing, then we're forced to create a new thing from scratch. But once we've created that new thing, we never need to create that new thing again. We just use it. So the marginal cost of duplication, what they talk about in manufacturing, is essentially zero for software. We are only ever doing new things. And because we're only ever doing new things, that's where a lot of the unpredictability comes from.
I think that's a fundamental nature. But still, it frustrates executives, right? Because
they are so easily frustrated. And it's human nature, right? We hate uncertainty. We hate unpredictability. We're always looking to try and control, to try and predict the future. And we've been doing this for centuries, right? Ever since, we were hunter-gatherers, like back in prehistory, we've been trying to control the future. We've been sacrificing to the gods of hunting in order that we have a successful hunt and bring home meat for the tribe. Right? We've been looking to predict and control the future since forever. Right? So it's a natural human instinct to try and do that. But from a Cynefin standpoint, right, we know that if we're in the complex space, that prediction is essentially a waste of time. Even if you do manage to find a strategy that works, then it's not going to work in different context, and it's not guaranteed to continue working, because as time passes, the environment will change and your strategy probably won't work anymore, and you'll need to come up with a new strategy. So probe, sense, respond, right? So with this in mind, so there's this, we talk about what can we do instead, right? If we give up control, if we give up prediction, what can we do instead? So this is where Agile comes from. The whole point of Agile is don't rely on prediction, don't rely on plans, just deliver stuff incrementally. So instead of prediction, we're using reaction. And we're enabling reaction to be more useful by shortening the feedback cycles. Yeah. So we slice things really thinly and we attempt to get valuable feedback, preferably from the customer, as soon as possible.
But the challenge here is the one that you mentioned in the beginning. if you have a product, you see where things are going. Let's say you are responding, you are adding a new feature. Like, let's say, users asked for a feature, simplest case. And you look at it and you say, okay, that sounds like a good one. Let's build it, deploy it, and so on.
Mm-hmm.
It's still impossible to say whether what happens next is because of this feature or something else. And I guess this is another fundamental problem, right, with software.
I think somebody talked to me like way back about the problems with Scrum, and all of the problems that they thought there were with Scrum, I didn't think actually were problems with Scrum. But one of the things that I did think was a problem that wasn't often talked about is the fact that the product owner is a really key position in Scrum, more so than any other role in the team. If you have a good product owner and a mediocre team, you'll still probably do okay. But if you have a bad product owner and a fantastic team, the result is going to be terrible, right? Because you've got people doing the work right, but doing the wrong work. And I think this is another one of those cases where a good product owner has a sense, an intuition of what is valuable to their customers, because they have empathy with their customers, and what isn't valuable. And that's really what they bring to the table. And this isn't really about measurement, because this isn't really about quantifiable things. It's about qualitative measurements. It's about an understanding of your customers at a deep gut level.
We have a training for agile product management, and we go a lot into this, that you need to get into, have an empathy for customers, understand them more, and so on. And then at some point I found a talk that was very interesting from a product manager who did a support system. So the system that would call the developers in the middle of the night when something happens. And one thing
everybody's favorite.
Yeah. And one thing he was saying is you cannot put a money value on everything. Because, for example, one thing that we did was hire a barbershop quartet to record some nice songs to play to those people who are woke up in the middle of the night. And what's the return on investment for that? Because it's impossible to measure, but we did it anyway because some things are not measurable. And this only comes from empathy, as you were saying. I found it as an excellent example of empathy.
It's, yes, not everything that can be counted counts, and not everything that counts can be counted. It's difficult. So Tom DeMarco is one of my favorite software authors. He wrote Peopleware. Back like in the early part of his career, he wrote, you can't control what you can't measure. And he was one of the most quoted people in software engineering and software metrics. And there's a really nice quote that I have, because 40 years later, he was interviewed by the IEEE. Basically what he was saying is that he seemed to think that control was the most important thing back then. But he realized now that control is not the most important thing. There's two kinds of projects that he talked about. There's a project which generates $1.1 million of value, but has $1 million of cost. And there's another project that has the same cost, but generates $10 million in value. And he says, for the first kind of project, you can see that control is really important, right? Because if you run slightly over budget, then all of your profit is gone. But for the second kind of project, control isn't really important at all. And thus, he said, it leads to the really kind of bizarre situation in which when you find that you need to control things, this actually is telling you that you're working on the wrong kind of work. You're working on the kind of work that has only marginal value. And he said the real question is, why are we doing so many of the first kind of projects and so few of the second kind of projects?
Yeah, and this reminds me of a realization I had about technology in general, that technology doesn't really add to the skills that people have, but amplifies them. So if you have a hammer, you'll be able to kind of hit smaller things and with more power or something like that. But it's not something that you wouldn't know how to do. You would presumably be able to do the same by the fist, although not in a very nice or pleasant manner. And it's the same with this type with software technology, because what we have now is, I find it amazing that, I can start 1,000 virtual machines everywhere in the world by sitting here and running a command. And that's the actual power of technology. And I guess this relates to these types of projects, because we could do projects that actually have this immense added value, right?
Who was it? Was it Newton that said, "Give me a lever long enough and I will move the world"?
I think I know Galileo with this, but...
Okay. I'm just guessing, so you're probably right. So Buckminster Fuller said, we must do away with the absolutely specious notion that everyone has to earn a living. It is a fact today that 1 in 10,000 of us can make a technological breakthrough capable of supporting all of the rest. The youth of today are absolutely right in recognizing this nonsense of earning a living. We keep inventing jobs because of this false idea that everyone has to be employed at some kind of drudgery because, according to Malthusian Darwinian theory, he must justify his right to exist. So we have inspectors of inspectors and people making instruments for inspectors to inspect inspectors. The true business of people should be to go back to school and think about whatever it was they were thinking about before someone came along and told them they had to earn a living.
Yeah, this is, well, I think we could do a show only on talk about this quote. But yeah, I wanted to pass by you another thing that I was thinking of. Kind of going back to the first principles of software development. And one way I am imagining software development is that, well, you have an input and an output. And generally, people, when they talk about inputs and outputs in software development, they refer to various things. But the way I imagine it is you have a team in the middle. The input is very unrefined knowledge. It's things like, we would like this to happen somehow. Or, to have payments or to have whatever, reports.
A requirements document.
More or less. Wants and needs. That would be the least refined form of, requirements, wants and needs. And then at the other end, what we get is actually very refined knowledge, which is refined enough so that the computer can run it. Because that's basically what code is. It's
a mathematical construction.
It's encoded knowledge of some sort that also happens to run on a computer, basically. It has
Shannon's information theory.
Yeah. And so one way I've been picturing this is that teams are fundamentally knowledge refineries. So then if I were to measure productivity of a team, it would most likely be in terms of how fast they are refining knowledge. Now, of course, there are a lot of issues with this. First of all, being that I have no idea how to quantify knowledge. But I wanted to pass this by you as a wild idea.
This doesn't seem so far away from stories. Right? Let's measure stories. And I think it's good insofar as it goes, but it's It's perhaps necessary but not sufficient. So the problem is when you start using this as your sole measure, and then Goodhart's law comes into play, which is any measure that's used as a target ceases to be of use as a measure. Because of stuff like, in this case, technical debt. Right? Because it's more than just refined knowledge. Right? It's also the design of the system. And the design of the system has qualities that exist outside of, does it take the input and create the output that is expected? Right? So there are non-functional aspects to the system's qualities as well as functional aspects. So if we measure the functional aspects but not the non-functional aspects, then we run the risk of negative externalities of the system, like technical debt, which will later come and bite us. As Vanderbilt said, any idiot can run a railroad. Right? You just stop investing in rolling stock and the actual rails, the rail network, and watch the money flow in for a short time until everything, until the rail network goes rusty and broken, and your rolling stock ceases to work because you haven't been maintaining it.
All right. So then we should add to this a function of the way existing software is organized, more or less, because that is probably more, how would I say, has a larger effect than the actual implementing of a new story, let's say.
So then you come back to the question of, how do you measure quality?
Yeah. Exactly.
And, and I think people have struggled with this for a few thousand years or so.
Yeah.
I'm not sure we're going to get an answer to that anytime soon.
Yeah. No, it's still difficult. Okay, let's talk a little bit about let's say, the second level effects. So when you start measuring something, what happens? Because you mentioned the Goodhart's law, but I think there are more things there.
So, yeah. So there's lots of different things. So we talk about the observer effect in physics, which is if you measure the position of a particle by bouncing a photon off it, then you've measured its position, but also you've bounced a photon off it, so now it's moved. And the more general sort of statement of the observer effect is that it is not possible to observe a system without changing the system, because both the observed and the observer are part of the same system. And we can see this in the Hawthorne effect, which is where I think it was General Electric, the Hawthorne factory, they decided to run some experiments on whether increasing the lighting level would help the productivity of their workers. And they found that it did increase the lighting level. They did increase the productivity of the workers when they increased the lighting level. And I thought, that's great. But are we sure of cause and effect? So just to double check, they decreased the lighting level and saw what difference that made. And that increased the productivity of the workers. And they were like, but how? This can't be true, right? Surely if you decrease the lighting level, the workers should be less productive, not more productive. And what they realized, in actual fact, is it was the inspectors who were counting the number of items that the workers were producing that caused the effect, not the lighting level. The fact that they were observing the system was changing the system.
Yeah. And I guess this happens with any metric in software development. I've been around in teams that got all kind of weird metrics that were measured, and I even was in a team at some point where we were discussing about the number of lines of code, so as a metric. And at some point I deleted all the commented lines of code, and so we had negative productivity for a few weeks because of that. But fortunately we got over that quite quickly. But generally what happens is that the team will start reacting to this, particularly when it's linked with things like career and salaries and
Oh yes. So apocryphally, IBM in the 80s introduced a bug bounty on the System 360 development program. And the idea here was that they would offer $5 to every tester who found a bug. And then they would offer another $5 to a developer who fixed that bug within a certain time limit, like a week, say. And almost overnight, an underground economy in bugs appeared, where the developers would write bugs into their code, note down the location and behavior of the bug in little black books, which they would then sell to testers.
Sell?
Where the testers could discover the bug, and then bug would go back to the developer who would already have a fix in place for it. Needless to say, that program didn't last very long.
Yeah, I know the Dilbert strip with we are.
I'm going to write myself a new minivan over the weekend.
Exactly. Yeah, it's very hard. So then, does it make sense to measure anything about development team or?
Yes. So there's the question about, can we measure individual developer productivity versus can we measure group developer productivity or group team productivity? And again, I think the real question is, what is the actual question that you're asking? Right. So a senior manager at the BBC once told me that the only time that they ever look into kind of, code commits and merge requests completed in GitHub, GitLab, whatever. The only time they ever collected metrics on team members was when they wanted to fire someone. Right? And they already knew who to fire, right? They just wanted some ammo so that they could justify this to HR. That was their only reason for using metrics.
So it wasn't even the metrics of everyone, it was the metrics.
No, it was literally just finding a reason that wasn't nobody likes this developer. So yes, there's a whole book, and I think I've got it over here somewhere. Yeah, here we go. It's called The Tyranny of Metrics, and it's all about how measuring things creates dysfunctions in systems. And they have examples from education, from healthcare, policing, you name it. It's an incredibly well-researched book with like hundreds of references to peer-reviewed scientific research, which shows that we are building systems that we think are based on like operant conditioning, on like punishments and rewards for outcomes delivered. And yet what we are actually doing is shooting ourselves in the foot. And there's a fantastic story from Freakonomics where there's a daycare center in, I think it was New York City, where they are having problems with parents coming late to pick their children up from daycare. And so they decided that in order to try and dissuade parents from coming late to pick their children up, they would punish them by instituting a fine of, I can't remember how much it was, like, $10 for every half an hour they were late or something. And what they found is that instead of curing their problem of late pickups, it actually made it worse. because now parents weren't feeling guilty about picking their child up late. They were viewing it as a paid service.
Yeah, I remember.
And the daycare center's like, oh my God, this is precisely the opposite of what we want. Quick, take the fines away. But now, of course, it's too late. Instead of being a paid service, it's now a free service. And the damage was already done.
And I think that's a very good and contained example of what can happen with a system. Because not only you measure things and you introduce incentives, but it also evolves, and then it's very hard to bring it back to where it was. I think that's one of the lessons. I mean, when the pandemic started, many people were expecting that, the pandemic will end and then everything will go back to normal, whatever normal is.
Yes.
When I was thinking, look, the pandemic will end, but will be in a completely different place because we've disrupted everything. So it's impossible to go back. The system will just move forward.
The world has changed.
Yeah, the world has changed. And you kind of do the same when you start measuring things and linking it to incentives inside of a company. You can produce changes that are lasting, if not, let's say, undoable.
Dan Pink's book on autonomy, mastery, and purpose, I can remember him citing research in there that showed that when given creative tasks, subjects were actually less productive if they were offered a reward.
Yeah.
So when there was a monetary incentive for doing things, they were less creative. So arguably, while it might work for, rote work, packing boxes of strawberries or something, for any kind of creative task, that incentivization just gets in the way.
So then we are only left with a reactive way of working, right?
I think yes. There's if we give up the need to predict, then we need to enable the ability to react. And part of that, I think, is about short feedback loops, but part of it, I think, is about team autonomy as well. Because you can't react quickly if you need to get 7 levels of sign-off for the change that you want to make. I think another part of this is accepting that you can't control everything, or even maybe anything, and instead focusing on collaboration and co-creation. If you're part of the team, stop trying to control other people's reactions and instead work with them. And if you're not part of the team, trust them to do a good job and let them get on with it.
But then if we go back to the initial questions, who do I fire? Who do I promote?
So I think the who do I fire thing is, well, you probably shouldn't be in the position of having to fire 50% of your staff in the first place, because that's just poor management. So when COVID struck, what's his name? The CEO of Gravity Payments, the guy who decided that the research had shown that $70,000 was the minimum average wage that you could be happy with in whichever city they were in, Seattle, I think it was. So he immediately raised the minimum wage in the company to $70,000. It didn't matter what you did, even if you were a janitor, you got $70,000. And he did the same for himself. He dropped his $1 million paycheck to $70,000. So at the beginning of COVID, they expected that there would be a lot less payments going through, so they'd be making a lot less money, so they might have to downsize. And instead of just saying, oh, I need to fire 20% of my staff, he instead engaged with the staff. He started it off with an all hands meeting and said, look, okay, we've got a problem. The forecast looks poor. We're going to be making less money. What are we going to do about this? And the staff unanimously said, we'll all cut our pay by whatever it was, 20% or whatever, because we don't want to lose anyone.
I remember reading about that, and it was quite impressive. There are a few examples of such management, but only very few, I'm afraid.
Yes, and it's sad that more companies don't work that way. But that has to be the future, right? We have to be more caring, more kind, more compassionate, more empathic. You can't continue to treat people like disposable resources.
Absolutely agree. But then what about deciding you have $1 million and the potential to do 10 projects?
Actually, hold that thought a second. Let me go back to the, not I've been told that I need to fire 20% of my staff, but the kind of, I'm worried that someone isn't performing well, or I'm worried that there may be people unidentified who aren't performing well in my teams. How do I identify those? And I think the answer is very simple. It's the sniff test. If you go into like an Airbnb and you go, and it doesn't smell right, you don't need a metric to tell you that something's wrong, that someone didn't do a great job of cleaning up, right? And I think the same is true in teams. I think if you ask any team member, do you think anyone here is struggling? Pretty much they'll instantly be able to tell you, no, I think everyone's doing a good job, or, well, Graham's struggling. And you might not know why. And people's reasons why they think Graham might be struggling are probably wrong, because we like to make up our own narratives around things given the absence of information. But that rarely is actually the case. But what you can do is identify that someone does not appear to be performing well by asking, like, all of a team individually. Because some people might just not see Graham's work and therefore think that Graham isn't doing anything, when in actual fact they are. But if most of the team are like, yeah, I think Graham's struggling, then you know, okay, I need to have a conversation with Graham and figure out what's going on. Is that actually the case? If so, why? What can I do about it? I had, back early in my career, the first team that I ran on a software project, there was a young graduate called John, who was part of the team, and he would not turn up on time in the morning when the rest of the team would. He'd come in late, and there'd always be some new excuse, and sometimes he just wouldn't even turn up at all, and no one would know where he was. And after a week or so of this, I pulled him to one side and had a private conversation with him and said, look, I've noticed that you don't make it in on time into the office, and some days you're not even turning up at all. What's going on? And he told me that the previous week his father had died.
Yeah.
And that he was struggling to cope with it.
Perfectly understandable. And
the only thing to do in a situation like that is to say, take time off.
Yeah.
Take compassionate leave. Do what you need to do.
Yeah, it's with these stories that, I mean, I like teams where we value professionalism, and in the beginning of my career I didn't value empathy as much, but today I value empathy equally as how good we are at our job. But it's also to remember all times that you are working with people and for people, and because of this you need to understand what's going on beyond the lines of code that you are writing.
I like to liken software systems to a Parma ham sandwich. Computers don't design systems, humans do. And computers don't consume the output of systems, humans do. So the computers are just like this thin layer of Parma ham in the middle of a sandwich with two fat pieces of bread. It's almost all humans in the sandwich, right? And only a thin layer of computers. Computers just join the two groups of humans together. It's mostly about the humans.
Yeah. So if I can go back to the previous question, which was, if we are not using metrics, where do I spend the budget? How do I allocate?
A capital allocation. So there are solutions for this, and we can look to portfolio management for some examples of this. So Don Reinertsen talks about this in the Principles of Product Development Flow, where he talks about the cost of delay divided by duration. So if we can understand the cost of delay for a piece of work, then we can prioritize pieces of work against other pieces of work. And by definition, those costs of delay are estimations. But if we slice the work thinly enough, we can get feedback quickly and we can see whether those estimations are accurate or not. And that's the way we need to manage our portfolios of work. Yearly budgeting, a yearly feedback cycle is just way too long. And I don't think things were different at the beginning of software development in like the 60s and 70s. Right? I think even back then, when we'd like to think that the pace of development was a lot slower than it was, a lot slower then than it is now in the modern day. I think even back then, a year was too long to wait for feedback. So I think we need to be talking about weeks, or at most, 1 or 2 months for feedback before we start then going, okay, is this doing as well as we expected? What is its actual revenue that it's bringing in? How much profit are we getting out of that revenue? And do we want to stop doing work on this thing in order to do work on this other thing, which is more valuable? And if you're not doing that kind of constant review of capital allocation, then it's likely that your business is not doing anywhere near as well as it could be doing.
Yeah, that sounds like an appropriate way of dealing with that, but I'll have to look more into how it's done operationally, because that's...
So back when I used to work for Simply Business, we had something called the Decision Den. And the way that worked is that product owners brought essentially business cases for work they wanted to do, together with back-of-the-envelope style calculations on how much they thought it would be worth, how much revenue this would bring in, or how much costs it would save, or what risk reduction was there for doing this. And then there would be a kind of, Dragon's Den style interrogation of the representatives from product in order to make sure that they had, in actual fact, thought about all of the things that they needed to think about. And then they would be given either a, yes, go ahead and do this. This will be funded. No, we don't think that this will either make enough money or make more money than the other things that we could be doing right now. Or a, take this away and go and find more information. go and qualify your estimates and then come back to us. And that worked reasonably well, but the thing that they didn't do quite so well is they didn't close the loop. So the idea was that after you'd done the thing, you'd come back like 3 months afterwards and you'd present, okay, this is what we said it would do. This is how much we bid for in terms of funding. This is where we are now. This is how much revenue we've got versus kind of where we said we would be. And, you know, yes, we're kind of on target, or no, we're under target, or, you know, we're doing better than we thought we would. And if you're under target, you're like, well, what are you going to do about that? And that was the intention of where it would go. But during the time that I was there, it never actually got to that closing the loop piece. I hope they did eventually.
Eventually, yeah. I feel that many businesses fail to look backwards. I mean, they make a decision and they kind of run forward instead of
sunk cost fallacy,
closing the loop. And yeah, or it's just that they feel pressure from the market and so on, and kind of run ahead instead of trying to close loops and figure out how to get better. All right. Well, we've been at it almost 90 minutes. I think there would be much more to talk about, but I also think that we touched on the most important things for now. So before we close, is there anything else that you'd like to tell our audience that maybe we haven't discussed?
No, just to say thank you very much for having me on your broadcast. It's been a pleasure, as always.
Well, thank you for coming back and bringing your expertise into these things, to metrics.
I guess the only thing to add is that all of this and more will go into a blog post, which I'm in the process of putting together. Which I hope to release in the next week or so.
Let me know when you publish it, and I'll make sure to promote it.
Thank you. I will do.
And so on. All right. Well, thank you. It's been a pleasure. And I'm going to close now. So thank you, everyone, for watching and listening. You heard a lot of interesting information about metrics. What do you think about this? Let us know in the comments. We love comments. And
we do.
And we love to answer to them, and we actually have a lot, not as many as I'd like, but quite a few interesting conversations on the YouTube channel. So I quite like the comments that we get. It's starting to get into a nice community, I think. Thank you kindly for the view, and until next time, remember to think design and work smart.